Okay, we are going to talk about the word problems that you have on your practice page. And a couple things about the word problems. Because it's Pythagorean theorem practice, we know we're going to be creating triangles. Okay, so these word problems, we definitely want to illustrate each one. We will have right triangles, and it's going to be very important that you read the descriptions of the situations so that you know where the values go. You'll have two numbers given, and you'll have to decide where the information falls on that triangle. Okay, so our first situation, Kate biked 9 miles north to the park, then 4 miles west to the mall. How far is Kate from her starting point? Okay, so the reason they talk about north and west is because we know north and south are a vertical direction. West and east are a horizontal direction. So if I go north, if I start at this point and I go north and then I turn and go west, that creates a right angle. So if she goes 9 north and 4 west, that gives me a right angle here. So this is her starting point and this is her ending point. We want to know how far she is from home or from where she started. Imagine that's a straight line. Sorry. Oh my. There we go. Okay. So we want to know this value in between here. Okay. Now I'm not going to go any further than this. I'm just going to help you get the problem set up with the picture. Now it's up to you to use the Pythagorean theorem and decide what's the A, what's the B, and what's the C. Okay, next one. Troy is building a rectangular garden that's 10 feet by 6 feet. What should be the length of the diagonals to ensure a 90-degree angle? So there feels like there's a lot going on here, but let's just take it one step at a time. Troy is building a rectangular garden. Sorry. So rectangle. Okay. What we do know about rectangles is there are 90-degree angles, right? In all of my corners. Now this rectangle is 10 feet by 6 feet. The other thing I know is that our opposite sides here would be equal, right? Then it says, what should the length of the diagonals be to ensure a 90-degree angle? So diagonals, just a diagonal line goes from one corner to the other corner. It doesn't matter which side you start at and go to, but if I draw a diagonal, do you see how it creates a right triangle here? And it also creates a right triangle on my other side. So what we want to know is what would the length of the diagonals be? So this piece is what we're looking for. So if you look at my green triangle here, I know two of the sides, I know the legs, right? I need to find the diagonal. Pythagorean theorem. Number 3, a 15-foot wire is tied from the ground to the top, tied from the top of a pole to a stake in the ground. If the stake is 5 feet from the base of the pole, find the height of the pole. This is a very common problem that you'll see on tests. I believe it is a common standardized test type question. This question comes around a lot. So let's take a look and see what this says. A 15-foot wire is tied from the top of a pole to a stake in the ground. Okay, so the wire starts at the top of a pole. So let's draw a pole, like a flagpole. And I have a wire tied to the top. I'll label the pole. Now this 15-foot wire goes from the pole to a stake in the ground. right? There's my stake in the ground. This is my wire. This is my pole. This right here is the ground. I actually put the ground at the base of this. Okay. So it says if the stake, well, now the wire is 15 feet. It goes to the stake in the ground. If the stake is 5 feet from the base of the pole, so here's the base of the pole and here's the stake, and this is 5 feet. Find the height of the pole. So right at the end, it tells us what we don't know. We do not know the height of the pole. We can call that A, we can call that B. Now we know that it's either A or B because if you think about this, a pole in the ground makes the pole and the ground create a right angle. So I know the hypotenuse, I know one leg, I need to find the other. And finally, to hang lights up on his house, Garrett places a 14-foot ladder 4 feet from the base of the house. How high up the house will the ladder reach? Okay, so I have my house. Right? And I have a ladder that I'm going to set up against the house. Now, if you've ever used a ladder or seen somebody, the ladders lean up against the house. Right? You put the ladder on the ground. You put part of the ladder on the ground and it leans up against the house. Okay, so that's what the picture would look like. Now let's look at the information they give us. To hang lights, he places a 14-foot ladder. So I know the ladder is 14 feet. 4 feet from the base of the house. So if this is the base of the house, the ladder gets put 4 feet away. What we have here is we end up with a right triangle where my hypotenuse is 14 feet, one of my legs is 4, and I don't know the other leg. Call it A or B. Doesn't matter. Those are your setups. Now go use the Pythagorean theorem to find your answers.